into 0 to 1, or we take this as h raised power. If it is h, if I take that x plus I plus less than h, it will be h raised power l plus m plus n only. This we know. This is equation number 1. Okay, so this is, if we have proved that this resultant into if it is h here in place of 1, this will be the value. Similarly, if let me take this as integral u, okay, then u equal to. Similarly, if h plus y plus z is less or equal to h plus, let me take delta h. Here delta h plus delta h is h2. This is h1. We will take here h1 h2. I'll just explain them. That can be explained then in this way. Okay, x plus y plus z is less than or equal to this. Therefore, then the integral u is equal to this value, triple integral x raised power l minus 1, y raised power m minus 1, z raised power n minus 1 into dx dy dz is equal to the same value, v gamma l gamma n divided by gamma 1 plus l plus m plus n into h plus delta h whole power this value l plus m plus n, all the three powers. This we have proved in terms of h, if this is less than h plus delta h. Now if I subtract this first from second, this second equation will be there. So this means, okay, let me write here. Therefore, the difference of them, the actual value, if the values of the variables between h plus delta h and h are positive, okay, then are positive and are integrable, we may say, then u is equal to, the integral is equal to the difference of them. We have to subtract, okay, this minus that, so that means second minus first. So second minus first imply that this value will be the difference of them. This whole value is equal to, let me write these two values. This is nothing but gamma l, gamma n. Let me take common. This is 1 plus l plus m plus n, gamma 1 plus l plus n. The are taken common. So this will give us here within bracket, it is nothing but h plus delta h whole power l plus m plus n minus sign h raised power l plus m plus n. Okay, so this is difference of these two, second minus first one. What do we get here? This is gamma l, gamma n divided by gamma 1 plus l plus m plus n. Now out of this, if I take h common, let me write here, this is h raised power l plus m plus n common. Within bracket we will get 1 plus delta h upon h whole power l plus m plus n minus sign h raised power l plus m plus n. Okay, so this is value. Now if I take h raised power l plus m plus n common, okay, out of this, or let me express this function in between. This will give us, let me write here, let me change the mark. So it will give us gamma l, gamma m, gamma n divided by gamma gamma 1 plus L plus M plus N. Okay, now out of this, what do we get here? If I take H common, it will give us 1 plus delta H. Okay, so this will be H raised power L plus M plus N. If I write common, it will be within bracket 1 plus, if I open this by binomial expression. Okay, so this will give us 1 plus L plus M plus N, okay, into delta H upon H, and plus the higher power of delta H upon H I have cancelled. Let me cancel them. Okay, and this is all those values are cancelled. Okay, because they are, it's very small value. Delta H is very small value, so delta H square is further smaller. Then all those sums are left. Minus sign. This, if I take, okay, H minus, this is minus 1 here. This minus 1 plus 1 cancel out. Okay, let me write this as curly bracket. And this is curly bracket inside. So 1 and minus 1 cancel out. Only this value is left over. What would this and this? So this will give us, let me write here. Finally, what do we get? This is equal to, this is U we are this integral we are calculating. This is gamma L, gamma M, gamma N divided by 1 plus L plus M plus N into H raised power multiplied by this. Okay, L plus N, this is nothing but L plus M plus N into H raised power L plus M minus 1, because this H will come in the numerator here. This is minus 1 power into delta H. Other terms are left. Why? They are very small value, smaller terms here. So here we get delta H square, and other terms are very small values, they are left. Okay, so, and let me write here delta H square etc. are left as they tend to 0. They tend to 0. Very small value they are. All other terms are left here. What about this? This is given to us as, now this L plus M plus N. If I express this value, this can be written as gamma L plus M, and this L plus M. It will be, let me write L, gamma L, gamma M, gamma N. Now this can be written as, we know that gamma M plus 1 equal to how much? M into gamma N. Okay, since this is there, this can be written as L plus M plus N in one bracket into gamma L plus M plus N into gamma L plus M plus N. This value multiplied L plus M plus N. This value is cancelled out by this into H raised power. Okay, into, let me multiply this value. H raised power L plus M plus N minus 1 into delta H. Okay, so this value is finally obtained like this. This is gamma L, gamma M, gamma N upon only gamma L plus M plus N, no 1 is there, into H raised power L plus M plus N minus 1 into delta H. Now, so far as when X plus H, let me write here, when X plus Y plus Z, which is in Fx plus Y plus Z, this value, Fx, X plus Y plus Z, okay, less or equal to H plus delta H, okay, or less or equal to H here. So X plus Y plus Z are the variables lying between H plus delta H to H. It means their value, if I write here in place of X plus y plus z as h. So this is fh here, fh here. Okay, so and then this is h2, this is suppose h1. h1 between h1 and h2, that value can be written in terms of that one. And this delta h is dh, and this is h raised to power l plus n minus 1 into fh. Okay, so if I write this value, fx plus h is fh here, fh. X plus y plus z is lying between h plus delta h and h. Let me write here. Here, let me write. Here f x plus y plus z, okay, is different, is or differs from fh as delta h. This value is very small, very smaller, or is very small value. So this x plus y plus h is lying between h plus delta h and h. It means this x plus y plus h is lying between h plus delta h and h. It means delta h is equivalent to this. So this, it means fh in place of x plus y plus z, if I write fh is just equivalent to delta h, or is equivalent to fx or y, is or is just equivalent to f x plus y plus z. So these variables are lying between these two limits, h1 and h2. Okay, it means x plus y plus z, which is lying between h1 and h2. So h1 is less or equal to x plus y plus z is less or equal to h2. So we can write this whole. So this integral is equal to, therefore this fx plus, therefore fx plus y plus z into h raised power l plus m plus n minus 1 into delta h can be written as integral sign h1 to h2 into capital fh into h raised power l plus m plus n minus 1 into dh here. Delta h can be written as dh. Okay, so let me now write, therefore this whole value, therefore triple integral sign f x plus y plus z into x raised power l minus 1 y raised power m minus 1 z raised power n minus 1 into dx dy dz can be written as gamma L, gamma n, which we have just proved, gamma n upon gamma L plus m plus n, sign of integration h1 to h2 limits, and this is fh into h raised power, this we have proved, this L plus m plus n minus 1 it was coming into dh. Okay, so this is equivalent to this. This we have just proved. So hence this is proved. This is known as extension of Dirichlet's theorem. Okay, this is given by LOUISVILLE. LOUISVILLE was contemporary to Dirichlet. Okay, so this is the theorem proved here. For this fh, which is fx plus y plus z, x plus y plus z is lying between h1 and h2. So this we can write that this value, because this whole value is equal to this, and this is lying between h1 and h2. Or here h1 we took h, and this h2 we took h plus delta h. In that way also we can write, but we have just proved separately. Then we have replaced them by h1 and h2. Within these two limits, this value fx y plus z is lying. Therefore fx y plus z we have put here h, because h plus delta h to h. This x plus y plus z is equivalent to h in between. Okay, so this is equal to this, hence proved. So this is prove here. This is question number 2, which known as Liouville's extension of Dirichlet's theorem. Second question. These first 2 questions we have done. Okay. Now let me talk about what is the third question then. Now we have to prove these questions based on these theorems. Now let me take questions, third question onwards. Okay. Now question number 3. What does it say? Third question says, okay, all these questions are taken from student queries. Number of other questions are there, but I have taken only 8 because they are appearing only on this board. Okay, I cannot take more questions. I can take, but then the speech will be enlarged. Okay, so let me take only these questions. Question number 3. Now, what did you say? Evaluate triple integral sign. Triple integral sign here. Okay, and this is dx1, dx2. I think they are double integral, and up to dxn. Extend to all positive values of variables subject to the condition. What the condition? Subject to the condition. Subject to the condition. What is the condition here? x1 square, x2 square, plus and so on, plus xn square is less than r square. Okay, is less than r square here. Okay, if I write here is less or equal to r square, no problem, we can write equal also. So if I divide it, or x1 square upon r square plus x2 square upon r square plus and so on, this is xn square upon r square is less than 1. Only then this number will be real number. I mean, this is a number, the real number is there, dividing by r square. So we have this. If I write this is u1, this is u2, or uvw, let me take, no problem. So if I take, let u is equal to this, x1 square upon r square, v is equal to x2 square upon r square, and w, let me take, and w is equal to xn square upon r square. Okay, so what are these values here? Okay, let me take them one by one. So this is, we have to write here, then we will explain that in terms of that Dirichlet's theorem. Okay, so let me write the differentiation. Therefore, what is x1 here? x1 square equal to, from this equation, x1 square equal to, this implies that x1 square is equal to u into r square, or x1 is equal to r under root or u raised power half. Let me write x1 equal to r square root of u, that means u half, and x2 equal to, similarly, equal to r into v raised power half. Okay, similarly xn equal to, this is x2, and xn is equal to r into w raised power 1.2. Okay, so this is, and so on we have taken. Okay, so if I substitute these values there, and then what about dx1, dx2, dx3, that we have also to find out. Let me write here. This implies that dx1 is equal to, from this one, differentiating it with respect to u, v, w, let me take, it will be 1/2 differentiation into r into u raised power half minus 1 into du into du. Okay. Similarly, dx2 is equal to 1.2 r into x raised power, y here x2. This is x1. Here it is to v only. sorry, it is we have taken, it is v here, what I'm writing here, the u here, u raised power, here it is u, this first one is u, so u raised power half minus 1, similarly v raised power half minus 1, okay, similarly dxn in this case is equal to 1.2 into r into w raised power half minus 1. This is differentiation into dw into dv similarly. So writing these values in place of them, what do we get? This will give us, therefore we are solving here solution, we are finding out. Therefore this integral is equal to, let me write. What about the first one, dx1? What is dx1 here? Dx1 is given to us this value. Okay, no problem. So dx1 is equal to, we have to write only these dx1, dx2 like this. Only these values are to be written down. This will give us 1.2 r. Okay, this is 1.2 into r whole power n, because n times it will come out. For this r, 1.2 r, 1.2 r, 1.2 r, n times, whole power n times. I have to take common. Let me take. This is integral sign. This is only two integral signs. Then dot. This is only two integral sign dotted. Triple integral sign. Here I have to write all these values. What are those values? Let me write here one by one. That will be clear then. So first will be this 1.2 r. I have taken common outside, and then this is u raised power half minus 1, v raised power half minus 1, w dot to dot, w raised power half minus 1. Okay, so this we have taken here into du dv dot dw. Let me take dw. Okay, so this is what powers are 1.2 minus 1. This whole value by Dirichlet's theorem we know what it is equal to. This is equal to 1.2 r raised power n is here. This is 1.2, 1.2, 1.2. It will be gamma 1.2, gamma 1.2 up to n times gamma 1.2 divided by the whole value is by Dirichlet's theorem. Okay, so this will give us 1 plus 1.2 plus 1.2 plus and so on up to n times. What about this? This is nothing but 1.2 r raised power n. Now this is 1.2 or gamma 1.2 n times. Sorry, n times. Gamma 1.2 is under root pi. Okay, divided by this is gamma 1 plus 1.2 n times here. This is n times here. 1.2 n times. This is under root pi, because gamma 1.2 is root pi, is square root pi. This is nothing but 1.2 this value into r raised power n, 2 raised power n here. So let me write here whole power n. This is under root pi or square root pi. Whole power n divided by. Now this can be written as, so this is 1 plus this. Can be written as 1.2 raised power n gamma 1.2 raised power n. Okay, to 1.2, because whatever we write, this is one value less than this. It will be 1.2 whole power n into gamma 1.2 whole power n. Try to understand. This value is there. Okay, so this is again 1.2 whole power n cancelled out. So this is 1.2 whole power n into r raised power n is only left over. From this 1.2 whole power n cancel out. Okay, so this will give us, right here, what is the final value? This is r raised power n into root 5 whole power n. Okay, this is n times this, so we cannot write this, only let me write this. 1.2 whole power n, 1.2 whole power n is r raised power n, 1.2 whole power n, cancel out. Only this value Rn is upon gamma 1.2 whole power n is left over. Okay, this is under the gamma, this value, and 1.2 whole power n. This is the answer here. So answer of this question number, this is the answer here. Can we further yes, summarized? This is under root 5. This can be, because inside this is n power, not outside. It is only under 1 upon this 4 power n, it can be. Or we can add 1.2, 1.2 n times gamma 1.2 n times. It can be r raised power n only answer. But this is only 1.2, okay, 1.2 whole power n into gamma 1.2 n, but gamma 1.2, but gamma 1.2 is under root 5, we can write, and this is on. Answer can be written like this also, or we could write same value. That means 1.2 r whole power n, that was the same answer, and this is 1.2 whole power n here, divided by gamma 1 plus n upon 2. This is n upon 2 here, because n times 1.2. But this 1.2, 1.2, 1.2, n upon 2 times. This is answer, or this is answer. Both can be the answer here. 1.2 r raised power n, okay, that is there, and gamma 1.2 whole power n, that is there, upon 1 plus n upon 2. This is n upon 2, n times 2. This we can write this is n by 2 here only. This is not power n, but this is n times n upon 2 only. Sorry, this is n upon 2 only. This cannot be cancelled out. This is n by 2, not 1.2 whole power n. So this is a different one. This is not the answer. Okay, this is the only answer. This we calculated. So this is the answer here. For this is something different. Okay, this is the final answer. Question number 3 we have done. Question number 3 is done now. This is value equal to this. Final answer is this. Okay, let's take the question number 4. The question number 4 is question number 4 or fourth question. What does fourth question say? Or question number 4 says, this is evaluate this triple integral x raised power minus half, y raised power minus half, okay, and z raised power minus half into this value dx extended to all values of the variables subject to the condition x plus y plus z is less than 1. Okay, let me take question number 4 here. Okay, so question number 4 is we have to evaluate this question, double integral. Well, this is triple integral, sorry, triple integral sign x raised power minus half. Yeah, this is minus half, y raised power minus half, z raised power minus half within bracket. It is 1 minus x minus y minus z whole power 1.2 into dx dy dz. Okay, now if I write them separately, here this value, this is x plus y plus z is less than 1. If I take x plus y plus z is less than h, or is less or equal to h, then less or equal to h. So we can replace this x minus y 1 minus h, we can write it as 1 minus h. Okay. Now what about this value? That let me take. Okay, so that is equal to how much? Okay, question number, yes. Alright, so where is to, let me frame this solution here. Now this question can be written as triple integral sign. This is actually for minus half. The result is minus half here. We can write it as, okay, minus half plus, okay, let me write here like this, 1.2 minus 1, no problem, because minus half is the result, and y raised power also 1.2 minus 1, no problem, z raised power 1.2 minus 1, so difference will be negative half. Alright, and this is this value. If I write dx dy dz separately, and this is suppose 1 minus h here, with this I'll take separately, so this is 1 minus h here, or 1 minus x minus y minus z, still I'm writing. Okay, so this, if I write this value, this is nothing but equal to how much? And if I take this dh, okay, 1 minus h into dh, if I take, this is how much? This is nothing but gamma 1.2, gamma 1.2, gamma 1.2 divided by gamma 1 plus 1.2 plus 1.2 plus 1.2. Simple, because this is by beta functions. We have to convert this into beta half, and beta half, 3 times. This is this one. This value is equal to this one by Dirichlet's theorem. Because up to this point here we have taken. This is df dy dz with this also. And then triple integral sign. This is 1 minus x minus y minus z into dx dy dz with this also. But this value is dx dy dz. This we have taken here with this value, this one. Okay. If I write this as 1 minus h, or this is equal to h raised power, we could write it as h raised power, because this whole value is equal to, let me write here, h raised power, this we know, this is sum of all these 3 numbers, 1 plus 2 plus this 1.2, and this is minus 1 here, 1 minus h into, and the power is